theorem. Central limit theorem is one of the most important ideas in stats and data analysis. As we collect more and more data, the overall pattern becomes more reliable and start to form normal or bell-shaped distribution. Even if the small sample look random or confusing, large amounts of data usually reveal the true pattern. So I will explain with these examples. Coffee shop example. Imagine you own a coffee shop. Some days you sell 20 coffees per day, and some days 45, some days only 10. At first the sale numbers look completely random. But what happens if you have collect the sales data for like 30 days, 100 days, and 1000 days, or even more, 10,000 days? Something amazing starts to happen. As the amount of data increases, the random ups and downs begins to smooth out, and most values start gathering around the average, and the data slowly forms a shape that called normal distribution and also known as bell curve. So let's say we have average coffee sales are 100 cups, which we have our standard. If we have 100 values and this they 30 values or 1000 values, and we have like the average is 100 and the standard deviation is 20, right? This means most days sales stay close to the average. Important rule is 60, 95 and 99.7 rule. 68, 95 and 99.7% rule is like about 68% of the values that fall within a one standard deviation. If we have like average is 100, standard deviation is 20, so 100 plus minus 20 like 80 and 120. 95 and 95% of the values are in between two standard deviation, means 100 plus minus 2 standard deviation, 2 into 20 plus minus 40 from the average, which is 60 and 140. Now 99.7% of the values between 3 standard deviation, means 100 plus minus 3 standard deviation, 3 times 20, so 100 minus 60 plus minus 60, so 40 and 160. The real meaning of central limit theorem that teaches something important, that small data can be misleading, but the larger data gives a clear and more reliable picture. So this is our graph which explains and tells more of the things. Now let's understand this distribution chart. At first this graph is just like a bars going up and down, but what this chart tells us, it's how often different coffee sales values occurred. On bottom axis we have sales range, which is 40 to 50, 50 to 60 and 60 to 70 and so on. And the side of the axis we have frequency, which means how many times those values appeared. So notice something interesting in this chart. The bars in middle are much taller. That means the most coffee sale stays near the average. As we move forward, either left side or right side, the bars become smaller. That tells us the very low sales and very high sales happen less often. So these one taller bars, which says their values mostly around the average side. But when we go either side of the left or side, the bars smaller in size. So if the values are like, if we say is between 130 to 140, and so this happens very low sale or very high sale. This one, sorry, but the this 130 to 140, the purple one, right? So it happens less often. And if we say we have like this one, yeah, higher values, or they tell us very low sales and very high sales happen less often. And together these bars start forming a bell curve, right? The bell curve pattern. So this is called normal distribution, a bell curve. So in example, the average coffee sales around 100 cups per day. So natural, our most of the values are, if we say 90 to 100, this one, and 100 to 110, this one, and 90 to 100, this one, and 100 to 110, this one, and 110 to 120 is this one, and 80 to 90 is this one. So between 80 to 120, like this is the 68% of the value. As we move forward, 90% of the values, then move forward 99.7% of the values. The spread of the data is controlled by something called standard deviation. 68 within one standard deviation, if it's between, if 95% within a 2 standard deviation, if it's far from the average, 99.7, which is within a 3 standard deviation. A small standard deviation, the bar stay tightly packed. A larger standard deviation, the data spread out more. So when we used only a few data points, the chart looked random and uneven. But after generating thousands of values, the graph becomes smoother and more balanced. So this is the central theorem comes into the action. So that happens in other like business sales, the customer visits, exam scores, stock prices, factory testing. So a large amount of data usually reveals a predictable pattern. So this distribution chart is more than just the bar. It helps us understand where most values occur, how spread out the data is, whether the data follows a normal pattern.